So let's get right into it. We are going deep inside one of the most complex manufacturing environments you can imagine to see how a really groundbreaking partnership between Palantir and Panasonic is completely rewriting the rules. And look, this isn't just about collecting more data, it's about embedding real, actionable intelligence right onto the factory floor.
Our story really kicks off here with Panasonic Energy. Now, these guys are a massive global player, running factories at an absolutely incredible scale. Why? To build the lithium-ion batteries that are literally powering the entire EV revolution. I mean, these operations are beyond critical for the future of how we get around.
But when you look inside these giant buildings, you realize that making just a single battery cell is unbelievably complicated. It's this intricate dance between advanced chemistry, thermodynamics, precision engineering, and, this is the most important part, the skill of the actual person standing right there on the line.
And that leads us to a really fascinating, almost mind-bending question. How on earth do you take someone from a totally different world, say a casino dealer, and turn them into a specialist who can manage this kind of exquisite, high-end technology? Well, the answer, as we're about to see, isn't just more training. It's a completely new kind of software.
To really get the solution, you first have to appreciate the sheer scale of the problem. You see, battery manufacturing is just defined by extreme complexity. We're talking about thousands of variables, everything from the chemical makeup of the raw materials to the microsecond timing of these robotic arms, all of which affect the quality of every single battery.
And you know, the stakes here are unbelievably high. A tiny, microscopic defect, something you could never even see with your own eyes, can ruin an entire batch of product. And the consequences, as you can see, are really serious. We're talking about everything from short circuits to, well, worse. So getting this right isn't just about being efficient, it's about safety, plain and simple.
So you might be asking, why couldn't the old software just handle this? Well, the core problem is that everything was fragmented. Traditional factory systems, your old school dashboards or planning tools, they can see individual data points, they can see numbers. But what they can't do is reason across all these different things at once. They can't connect a problem on a machine to the specific batch of chemicals it was using and the person who was operating it at that time.
The best way to think about these older systems is as reporting systems. They're like this dashboard right here. They're great at showing you some charts and telling you what happened yesterday. They report on the past. But they can't tell you why something is going wrong in this very moment, and more importantly, they have no idea what you should do to fix it. They're just passive observers.
This is where the big shift happens. We're moving away from that old world of just passively watching fragmented data. The new goal is to create a true learning system, one that gives you actionable intelligence, because it can reason across everything at once. And it's all grounded in what is physically happening on the factory floor, right now.
So, how do you even begin to build something like that? Well, the solution starts with Palantir's Foundry platform. And the very first step is to create a living, breathing, digital model of the entire factory. This isn't just some static blueprint. It's a dynamic foundation that actually understands how every single piece is connected to every other piece. Now, the technical term for this model is a manufacturing ontology. And that phrase on the slide, a living digital representation of reality, that's the absolute key. This isn't a dashboard you check in the morning. Think of it as a real-time, constantly updating map of your whole operation, connecting every machine, every batch of material, and every worker into one single unified picture. And this diagram here does a fantastic job of showing how it works. This digital twin, as some call it, pulls in everything. Data flows from the production line, from quality control, from HR, you name it. It connects sensor readings from a machine with the chemical properties of the materials, the skill level of the worker on that shift, and all the historical data. It's the first time you get a single source of truth for what's actually happening.
But okay, having the map is really only the first half of the solution. Now you need an intelligent guide to help you navigate it, to make sense of all that interconnected data in real time. And that guide is Palantir's Artificial Intelligence Platform, or AIP. It's basically the brain that sits on top of that factory map.
I absolutely love this analogy because it makes the difference so crystal clear. Traditional software is like a paper map. Sure, it shows you the layout, but that's it. AIP, on the other hand, is like a self-correcting GPS that also has a mechanic built right in. It doesn't just show you the best route, it alerts you to an engine problem while it's happening, and then gives you step-by-step instructions on what to do about it.
And that's exactly what AIP does in the factory. It has these AI agents that are constantly scanning for problems and anomalies. When they find one, they can send real-time step-by-step guidance directly to a worker's tablet, helping them make smarter, faster decisions right there on the spot. Which brings us right back to our original, kinda crazy question. And here's the answer, straight from Palantir's CTO. He said, Panasonic Energy is using AI to train workers to manage exquisite high-end Japanese battery technology, where many of the workers previously came from casinos. It's just a powerful statement that shows you the incredible human impact of this tech.
And this is the most crucial point to understand. The AI is not there to replace the workers. It's designed to be a skill amplifier. It takes people, regardless of their technical background, and rapidly upskills them. It augments their own judgment and turns them into highly effective operators of these incredibly sophisticated machines.
And this is what it actually looks like. The worker on the left, using a simple tablet, is now empowered to understand and even control the enormously complex production line you see on the right. The AI is the intelligent bridge that connects the person to the process. At the end of the day, what we're looking at is a fundamental shift in thinking. It's the difference between a system that can only tell you about what already happened and one that gives you the tools to actively shape what happens next, moment by moment.
Here's one last way to think about it. An old dashboard is like a thermometer. It can tell you the room is cold. Great, that's a fact. But this new system is like a smart thermostat. It doesn't just know it's cold, it understands why. Maybe a window's open, and it automatically adjusts the heat to fix the problem. It observes, it understands, and then it acts.
And this is all leading to a bigger idea, a new category people are starting to call reindustrialization software. It's software whose value isn't just found in some abstract chart. No, its value is embedded in the physical world, in improving real-world execution. Its success is measured in making better batteries, not just making better-looking reports.
And that really leaves us with a final, massive thought to chew on. If this kind of AI can transform one of the most complicated factories on Earth and amplify human skill in this profound way, you have to wonder where else is it going to completely redefine the very nature of work and what it even means to be an expert.